So we're going to take a look at negative exponents and what happens with negative exponents. In order to do that, we first of all want to just take a look at just working with exponents in general. If I have x to the third power, that actually represents x times x times x. If I divide that by x to the second power, x to the second power actually represents x times x. So now what I can do here is I can cancel things out. X over x reduces down to 1. X over x reduces down to 1. I am left with 1x in the numerator, which is x to the first power. We do not need to write to the first power. So, one of the rules of exponents is when I'm dividing two numbers, in this case x, they have the same base, and they just have different exponents. What I can do with them is take those exponents, the 3 and the 2, and subtract them. So x to the third divided by x squared is the same thing as x to the 3 minus 2 power, which equals x to the first power. Once again, the exact same thing. Well, how this changes a little bit and gives us negative exponents is what happens in a situation like this. We have x to the fourth divided by x to the sixth. Again, what does x to the fourth represent? Well, it's x times itself 4 times. X to the sixth is x times itself 6 times. What I can do now is cancel out some of my x's. So every time I have an x in the numerator and x in the denominator, I can reduce it down to 1. And when I do that, I get this. 1 left in my numerator and x squared in my denominator. Therefore, using my rules of exponents, I can take x to the fourth divided by x to the sixth and write it now as x to the 4 minus 6, or x to the negative second. Well, we just proved that x to the fourth divided by x to the sixth is 1 over x squared. That means that x to the second equals 1 over x to the positive second. So, whenever we have a negative exponent, we are taking the reciprocal of the number it is working on, and it becomes a positive exponent, 1 over x squared. That's the very basics of this, but it can be used in all the math problems that we do here in Algebra 2.